question. You did talk about storage, because I think one of the things that we think of is storage of hydrogen and those sorts of things, but you can also store CO2 and you can store carbon, and so I see it all as part of the storage equation. And often people need to think through the full spectrum, which is your message. Thank you very much. Did we clap you? No, I think if we could all thank Ellen very much for what was a great presentation. Thank you very much. Have we got Slido questions? I'm getting used to going to Slido first, so people online get first bite.
One question for Daniel, for Cobalt from Daniel about, do economic assumption on hydrogen assume consistent 24-hour production? Will electrolyzer switching on and off in response to electricity market signal help? What's your opinion about that?
So the numbers we have in our analysis don't assume 24-hour production. They assume a electrolyzer that is cost optimized for the generation of the renewable plant. That sounds a bit complicated because basically there's a balance that needs to be had, an optimal point between the size of the electrolyzer you have relative to the output of the generator, depending on what the capital cost of the electrolyzer is. So we did a whole bunch of simulations that went to optimize that. But basically, in short, if you have a PV system, it's generating 30% of the time or 20% of the time, whatever the capacity factor you can achieve is. The economics that we looked at were for, and what we hypothesized would be the way you would be able to produce hydrogen at the least possible cost, is to have a dedicated large-scale renewable energy facility with an on-site electrolyzer. As soon as you connect to the grid, and assuming you have to pay grid usage charges, you ruin the economics, because you're looking at $40 a megawatt hour at least, typically for grid network charges. So we think that actually, as far as possible, you'll avoid a grid connection for the purchase of electricity. Although a grid connection may be useful if you want to export electricity at times of high pool prices in the electricity market.
A question from the floor. Yes, down here.
Hello, COBAD. John from Australia. I just wanted to ask your assumptions for the sweet spot you mentioned for transport of hydrogen. So you talked about trucks, but you also talked about pipeline for industrial applications in the medium to the short-term distance, or short to medium distances rather. You were assuming new installations rather than reusing existing natural gas pipelines because of the technical challenge, or that wasn't considered? That's because of diffusivity of hydrogen. You talked about the advantages.
Yeah, we looked at the economics of building a new pipe. We didn't come across a lot of good data on the economics of retrofitting pipelines. And they're likely to vary quite substantially depending on the condition of the pipe, its metallurgy, and of course the percentage concentration of hydrogen you want to transport through the pipe relative to methane. So we didn't look at the economics of that comprehensively. We focused instead on looking at new pipelines.
One further question from the floor before we go to any more Slido questions. We'll go to Slido next then.
So just to continue on this topic for Cobalt again. Again, Daniel from US is asking, you did not mention revenues of the electrolyzer owner from FCAS, and here the capacity factor is 3 times the arbitrage of battery powered by cells. Can you comment on that?
Sorry, FCS, do you mean frequency control ancillary services?
Yes.
Okay. Yes, we didn't calculate revenue from FCAS. As I mentioned, the costs of a grid connection are high, and that's an immediate barrier to any any money that you think you can achieve on the FCAS market. We also focused our analysis on alkaline electrolyzers because we were of the view, looking at the cost data, looking at the industry structure, looking at the pipeline of existing and proposed projects, that and the technical data about the performance of alkaline electrolyzers, we were of the view that alkaline is likely to be the dominant technology well into the future. And the response time of alkaline electrolyzers, although sufficient to handle the variability of renewable production, not fast enough to have, to earn you good money on frequency control ancillary service market. So in short, we didn't spend a lot of time looking at that. The second part of the question on batteries, I didn't quite catch. Can you repeat that?
I was just saying that the capacity factor is 3 times the arbitrage of the battery power.
Sorry, you want to add a comment? We'll have to get a microphone too if you want. Oh, well, ask it here. I'll take the microphone to you, and then.
Thanks, COVID. Rob Dickinson, Hydro City. It was, in particular, my calculations over the last 2 or 3 years of the Tesla battery here in South Australia is that the revenue is about 3 times the cost of arbitrage. So that wasn't forecast when they installed it. So that's my basis for an interest in FCAS. But you've answered the question, so no need to follow up from there. Thank you.
Yeah, I mean that's a good observation, but I think the circumstances right now in South Australia are relatively unique. We're talking about envisaging electrolyzers in 2030, 2050, when you would expect the penetration of batteries on the electricity network would be high, and they would probably, be saturating FCAS markets with capacity. But of course, that's something for debate.
Actually, Ellen, if I can ask you a very quick question. If you'd been here last week, Flannery would have been here speaking about kelp and growing actually kelp in the sea and sending it out and storing it in the deep ocean. Have you heard about that technology? And it sounds like from the way you're looking, you haven't heard of this. Actually, Professor Tim Flannery is saying that one of the big options for storing carbon is to take it by actually growing kelp in the sea and growing it in places where that kelp will then be swept out into the deep ocean. And he's calculated there is a chance to store massive amounts of carbon. I've never checked this out, but I was wondering if you had checked it out.
Well, the ocean alkalinity stuff, I mean, one of the, growing sea kelp and stuff, and then, so the ocean is a deep reservoir, so yes. That is one of the things that people are looking at. You just grow it and then bury it in the sea.
Yeah. A question here from Gus.
Yes, Ellen, I'm wondering if you could comment, please, on where you see potential to capture CO2 from industrial processes and then add, for example, either react it with hydrogen or other pathways to regenerate into a higher value fuel within an integrated cycle on the industrial context. Are you looking at that pathway? Can you comment on that one, please?
So, of course, that's not exactly, sustainable. As a stepping stone, and separating capture from conversion, that is probably a very important step. Probably not so much capturing from coal plants. I actually skip by that because coal plants are going away, so investing a lot of CCS in coal plants doesn't seem to make sense. But from cement plants and especially from bioethanol plants, for example, then it makes a lot of sense to capture the CO2 and then convert it into fuel. But if it is fossil carbon, just using it twice, it's not a very large offset. It's a good learning step that'll help us move forward, but it's not going to be a very good pathway to decarbonizing.
Question here. Bassam.
Bassam Dali. Looking at the projection of hydrogen prices and comparing it to the price of natural gas, is assuming that the natural gas price is going to stay the same and that market forces is not going to push it even lower. My question is, would hydrogen will ever be viable if there's no carbon price?
Ellen, are you going to ask her that, Greg, or Kobad perhaps? Well, actually, all of you answer it. I'm going to make you all answer it. Kobad.
Okay, yeah, that's a good question. I mean, what I showed was a static range of today's natural gas prices, and I think your premise is right. If you start to destroy demand for natural gas, you're going to see prices fall further, and you know, already natural gas prices are as cheap as 50 cents an MMBTU, maybe, in the Middle East, where gas really is just a byproduct, an unwanted byproduct of oil extraction. So we could start to see gas prices go to that level. And that's one of the factors which makes the transition to deep decarbonisation really challenging. Natural gas is probably not the greatest worry. The greatest worry would be in oil products. If you think about the world being flooded, if we start to destroy really substantial demand for road fuels, that just sends a whopping great price signal to oil upgraders to produce more petchems using oil products with very low prices. So in short, look, I don't think it's possible to achieve decarbonisation or, you know, the use of hydrogen without a carbon price. What we find in our analysis is that a carbon price is required in pretty much every application to compete against the cheapest fuel. And we deliberately looked at the cheapest fuel because of this issue. And also the fact that industrial production tends to locate at the places where you have the cheapest fuels. And, you know, we find that a carbon price will always be required to compete with those cheapest fossil fuels. And, you know, just based on the physics of hydrogen production, it doesn't seem possible that you could get hydrogen production, at least from electrolysis, or probably synthetic hydrogen production of any kind. I would hazard a guess, as low as the cost of pulling a fuel out of the ground for free. So my view is that yes, you will require carbon pricing, and I would go further to say to deal with this issue of the price of fossil fuels falling as demand is destroyed, you need to have even more stringent and robust methods, which are basically regulatory and bans. Just to say, you know, I don't care how cheap that thing gets, you can't use it. I think that's eventually instruments we're going to have to resort to.
Greg or Ellen? Greg?
I'll be heretical and just mention something. I'm a hard scientist, and what I'm going to be saying is definitely not hard science, but what has interested me over the last number of years is social pressure, especially forcing, for example, our superannuation funds to divest from fossil fuels. And I think there's a big element about what social pressure can apply and in forcing companies to have an about face. But otherwise, COVID, I agree with you that it's not going to be, even with the best photocatalysts, it's not going to come down to the prices, just drilling a hole in the ground and just letting stuff ooze out. I mean, that's just way too easy.
Ellen?
But it's not just the social pressures are there, but they're also, these companies are just starting to make these zero carbon goals, period. You know, we're seeing utilities all across the U.S. declaring they're going 100%. We're seeing states doing it. There's something like 25 states in the U.S., that's half the states, have declared they're going carbon neutral. So they're looking for how to get there. And carbon neutral isn't necessarily 100% fossil. That's why we're looking at the direct air capture, other ways to get to net neutral and negative. But the commitments are starting to be there, and that's the point of various leadership getting us there. A price in carbon would help. And certainly in the U.S., we view that depending on the election, within the next 4 years, one way or the other, there will be a price in carbon. There's price in various places. But yes, the price on carbon's going to be important.
And can I just speak as a commentator here? One of the experiences I've found in my research career is that narratives matter. If you don't have the language, you don't form the hypotheses and you don't form the policies. Everybody here is talking about a carbon price. There are many, or at least a significant number of greenhouse gases. And when we talk about a carbon price rather than a greenhouse price, we adopt a narrative that stops a lot of innovation. And I think as we go forward globally, at some stage we need to shift the narrative from a narrative about carbon to a narrative around global warming and all the factors that feed into that. And that'll force us to start thinking about conversion rates and exchange rates and things like that. That's me commenting as a contributor rather than a chair, but I couldn't resist that. Further questions? Yes, down here, Chris.
Yes, thanks. Just it's a variation on Gus's question a little bit, is that I heard Cedric earlier talk about synthetic fuel for aeroplanes, for large aeroplanes, as being one of the, if we go to, EVs, hydrogen cars and whatnot, one of the last things and trickiest things to deal with will be aeroplanes, and the big ones, that is. He mentioned synthetic fuels. Can I get a comment from either economic or engineering perspective on what they think the likeliest way for us to get those are going to be? Greg's comment, it's pretty easy to get avgas by just punching a hole in the ground and refining it. But if we don't do that, what would be the likely pathway to synthetic aviation fuel?
Ellen?
Well, the likely pathway is hydrogen plus air captured CO2, and the synthetic pathways are there. There's a few challenges, of course. Just like in the electrolyzers, one of the key challenges is the downstream processing wants to be steady state. And if we're using solar energy, then your feedstocks aren't necessarily steady state, and then there's storage. It's not that we can't do it. The pathways are known. Like everything else, can we do it at any kind of reasonable cost? So can we, looking at what it would take to get to, like, say, $3 a gallon of gasoline equivalent for jet fuel kind of numbers, or $3 a gallon, it doesn't look out of the realm of possibility, but it's going to take decades to get there. Right now, the problem, the airlines, I mentioned it very quickly, is, they're the certified processes, they've got a number of them, they're biofuels, but they're scaling up, not very quickly. And, the challenge is scale up and cost. It's doable. It's just the time is not it's not our friend right now.
Further questions? Bassam?
Nobody seems to be talking about the N word. Would nuclear energy be anywhere competitive for hydrogen production if hydrogen becomes the commodity, especially for transport?
I'm looking at Kobad. He can't see. I'm looking.
I would say in a word, no. The most important thing for cheap hydrogen production is cheap electricity. And one thing that all of the data on new build nuclear reactors outside of China tells us is that nuclear reactors do not provide cheap electricity. You're looking at levelized costs of well over $100 a megawatt hour. or more for all of the new build nuclear plants currently under construction. Could that change if you have a massive renaissance of a nuclear industry and a breakthrough in nuclear technology? Yes. Are any of those things likely to happen? It doesn't seem so. So the only instance in which nuclear could provide cheap hydrogen production really is where you have curtailment, or you have a old nuclear asset which is being economically outcompeted, which, say, for instance, you have in the United States, and some hydrogen production can give it a last life for just short-run marginal cost of production to help it pay off the last bit of its loans and that sort of thing. I don't think nuclear is a long-term option for water electrolysis. One thing which we haven't really looked at, but where nuclear could have a slight advantage, is the byproduct heat can be utilized to, say, have hydrogen production from solid oxide electrolysis, which has higher efficiency. So potentially you can make some savings there. But again, I would be surprised if its economics would compete with 2 cents a kilowatt hour solar or less in a $100 a kilowatt electrolyzer, which are all costs which I think we can have a reasonable degree of confidence can be achieved.
Can I?
Yeah, Slido's in a second. Yeah, Ellen.
So in the U.S., which, as just mentioned, there are still quite a few nuclear plants operational. The Palo Verde plant in Arizona is the largest in the U.S., and we are very definitely looking at and have a large-scale project going right now for hydrogen from the nuclear. Because as I said, APS is one of the ones who announced 100% carbon-free, but they are planning on keeping that nuclear plant operational. I would agree no one is looking at new nuclear, but the existing nuclear, which are base load, in a state like Arizona, who has sunlight like here in Australia, in the middle of the day, they're not going to want to be putting those electrons on the grid. So they're looking at making hydrogen. And the marginal cost is actually $20 a megawatt hour. So that's looking very attractive. And so a number of things. There's 3 nuclear plants doing pilots in the U.S. on hydrogen from nuclear.
Interesting. Slido questions.
2 quick questions for Greg. One is about what potential is there for photocatalytic hydrogen production from seawater? And then if you can comment on the long-term stability of your catalyst.
So let's start with the second one, the long-term stability. So with the photocatalysts that I mentioned in the presentation from Doman's group, so they've continuously tested them for over 1,300 hours, which is equivalent of about 7 to 8 months in the field. I think over that time there was a drop-off maybe of about 10 to 15% of that. So it's expected that they can have quite a long lifetime. So they are quite stable. They're not like some of the early ones where they would degrade within the minutes that you're taking the measurement. So there's been a big improvement there. And the first question was about the seawater. Yes. I'm going to answer this without giving too much away. That's an area that we're working on, but there has been very few, in fact, I can't even think of any reports of people doing photocatalysis with impure water or seawater. It's always distilled or some sort of milieu water. So I think it would foul up fairly quickly. Now, unlike electrolysis, where, of course, you form chlorine through the process with seawater, unless you take great care with what anode you have, I think that just hasn't been addressed in the research.
Watch this space, I think, is the code in behind that, Ellen.
Yep. So one methodology for for splitting water is the thermochemical, and that hasn't been talked about. And since that is, the water is steam, it could be made from seawater to begin with, because then you're not contaminating, because you're introducing steam into the process. So that's a pathway that hasn't been talked about.
One more Slido question.
There's one more for Kobat. If you looked at high temp steam electrolysis for future bulk hydrogen production, as it requires less electricity and higher production yield, if you ever looked into that?
We didn't focus on it. I mean, I would say one of the interesting things about hydrogen is that there are a whole bunch of very interesting and promising technologies, mostly at the lab scale. And one could spend a lifetime analyzing them all. Because we're a very commercial research entity, we focus on things we think have the greatest commercial potential. And in analyzing the clean transition for over a decade, what we quite clearly see is that the technologies which tend to achieve the greatest commercial success, achieve the greatest cost reduction, and make the most impact are the ones which build on an existing industry, which have an operational track record, which are being manufactured, which have entities which know how to produce them, which have engineers who understand the technology, which have financiers who have worked with those and lent money to those sorts of assets before. Photovoltaic cells, great example. That many excellent technologies continue to be many excellent variants of PV that work better than mono or polycrystalline silicon do, but those technologies continue to dominate because they built on the shoulders of the microprocessor industry, and so you had all of the industrial elements of scale up, and we think that the same is likely to play out with hydrogen production, and hence one of those reasons why we think that alkaline electrolysis is probably the most promising technology.
Where are we up to in the Slido questions? We've got one more, and then we'll come back to the audience here, and it'll be time to wind up.
Yeah, we just got one from John Pye from ANU. Would like to know about any view on how important is hydrogen in the domestic gas network, how important is likely to become, and noting that the competition from high efficiency heat pump with HVAC.
Kobat? You go to the short straw.
Yes. Well, this is something we've looked at because we've done a study looking at hydrogen for space and water heating, as well as looked at the economics as best we could of blending into the existing natural gas network. How important it's likely to become is a difficult question to answer, because what's likely to drive it is less about just competitive economics and more about strategy and asset values of existing players. So one of the reasons why hydrogen has gotten good momentum is because the natural gas industry has begun to embrace it, and particularly pipeline asset owners who are viewing hydrogen as their plan B, probably along with biomethane. It's in their interest to have a clean fuel molecule so that the asset has continued use and value. So they're likely to keep pushing the barrow of hydrogen as a replacement to natural gas in the network. Although there are no easy answers and clear-cut answers as to whether that is the best economic proposition. And why it's really difficult to tell is because there are all these complex case-by-case second-order and second-order issues on understanding the economics. So if you look, if you try to answer the question of what is the cheapest method to decarbonize space heating, and you try to do an analysis of looking at the economics of, say, an electric heat pump powered by renewables versus hydrogen through the gas network, you run into all of the difficult infrastructure questions about, okay, how much do you need to upgrade either option in order to deal with that and meet the heating demand. They're very complex and questions that vary case by case, network by network, town by town. So there's no conclusive answer. So I think it's just one we have to sort of wait and see. And than necessarily pure economics.
One last question from the floor or from Slido. Slido.
One last question for Ellen. I wonder if there are any synthetic mineral system analog to a calcium carbonate that could be used for carbon capture. If you are aware of any new synthetic mineral system.
Microphone.
Sorry, are you talking in like accelerated weathering or in artificial materials? Do you know what the question? Because, I mean, alternatives to cement, other carbonate cements and stuff, I think they're looking at iron. I'm not an expert on this, but there are other carbonates besides calcium carbonate. I know some of the companies that are trying to turn lime back into limestone, I don't think that makes too much sense, but there are people certainly doing that. That is the calcium carbonate, but there's also iron carbonate, magnesium carbonate, so there are definitely a range of carbonates that people are looking at,
Yep.
some of which are just natural accelerated weathering and some are artificial materials.
Yep. It just came up another question from John Pye again, from ANU, for Ellen again. He's asking about, we heard about cheap CO2 extraction from air, but a big issue here is the need for CO2 splitting to make that CO2 useful. How we are going to do that?
How are we going to make, I didn't,
I repeat, we heard about cheap CO2 extraction from air, but a big issue here is the need for CO2 splitting to make that CO2 useful. How we will do that?
okay, so that was, you know, the slides I skipped. Actually, I don't know that I call it cheap CO2 from air, but yeah, if you really want to split the CO2 and turn it into a product, only about 10% of the cost is going to be the extraction from the air, and then another 90% to actually re-energize it and convert it back into, you know, something like into a fuel or a plastic or something else. So that comes back to the question I think Chris asked about making jet fuel. You know, how are we going to get those costs down? We have to first get the cost. We have to get both the cost of capture and conversion down, and it's not a trivial challenge, but it actually does look doable.
Thank you very much. We're out of time, so I'm going to ask you all to thank Kobad, Greg and Ellen for excellent presentations. Thank you very, very much.